A quick introduction to soldering training. Our goal is to solder better by knowing how it works. We're going to learn some trade-offs, some best practices, what not to do, and some additional resources by looking at some demos. The first important thing to know about soldering is that it's all about creating alloys. Here you can see some scanning electron microscope pictures of the alloys that are created when you're soldering for both leaded and non-leaded types of solder. There are a few main factors that influence how well this alloy is made. First, the type of solder you use, leaded or non. Next, the temperature. You want to make sure that everything is at a consistent temperature while soldering. You want to get rid of any impurities that can degrade the quality of the joint. And last but not least, we're going to teach you a good technique that makes sure that your solder joints are always reliably created. In terms of types in solder, there's two main types. There's leaded and non-leaded. You can tell the leaded ones because they'll have PB, the symbol for lead, somewhere on the label. Here's an example of some lead-free solder. And we'll talk about more about which is better in a little bit. One very important thing is that soldering only wets to metal at the right temperature. Wetting is the term for how metal flows over, how the solder will flow over the metal you're trying to connect. There are different temperature ranges for leaded solder and non-leaded solder. So use the right temperature range for what you're using. And it's a Goldilocks problem. Try to make sure it's hot enough that the solder will flow and cold enough that you don't burn anything. So always start at the lower of the temperatures for the type of solder you're using and work your way up until you're until you see that the solder is actually flowing. Temperature, again, is very important, and you need every piece of metal that you're trying to connect to be at the same temperature. So you have to conduct the heat from the tip of the iron to every piece of metal. Consider the thermal mass. Try to place the iron at the place where things are thickest or largest. And any oxides or corrosions will prevent the flow of heat, so make sure you clean those off before soldering. Last but not least, any sort of liquid like the liquid solder itself or flux, which we'll talk about in a bit, can help transmit heat and get you started in the soldering. Speaking of impurities and flux, impurities like say oxides or any sort of corrosion on the metal that you're trying to connect will affect both the mechanical and electrical performance of the connection. If we have an acid there while we're trying to create the alloy while it's under temperature, it can carry away those impurities. However, you got to be careful because these acids continue to etch away. You can see an example of how corroded things can get if you don't clean your boards right over here. So what you want to do is make sure you always clean your flux when done. And remember, flux is an acid. Don't expose anything to it that you wouldn't pour acid on. So be very careful with it. Try to use as mild as possible flux and always solder in a ventilated location because you're exposing this acid to high temperatures and you don't want that in your lungs. A few things on types of flux. Many solders are sold with flux in core. That means the wire solder itself has the flux built in. And this is by far the best way to go. It has exactly the right amount of flux so you don't use too much. And it makes your life easier. You don't have to put anything on separately. You can get in other form factors, but in terms of the chemistry, you want to either stick with a rosin mildly activated, or better yet, a no-clean or water-soluble flux. You should clean those anyways, but the lower the acidity, the better things will be. Last important note, most fluxes are temperature activated and will burn up when exposed to heat, so if you feel like it's suddenly not working anymore, you might need to just grab a fresh piece of solder with the in-core flux not burned out. Back to the leaded versus non-leaded question, there's a few trade-offs. There's something called the restriction of hazardous substances, which bans substances like lead and mercury in order to protect the environment, but not you. Because non-leaded solder requires higher temperatures and doesn't flow as well, people usually incorporate more active or acidic fluxes. So it is an open question. What's safer for the user? You have a responsibility to make sure you dispose of things like lead safely, and you also have a responsibility for your own safety. If you are at all concerned, contact an instructor and we can make sure you work with what's good for you. A few other safety considerations. There is a slight splatter risk while you're soldering because of the flux, so you want to make sure you wear safety goggles or glasses. Typical glasses will work fine. There is a hazard to your lungs because we are exposing things to heat that will cause a smoke, so make sure you use appropriate ventilation or fume extraction devices. There's of course a fire risk. The irons get hot, so leave the iron off and in the holder when not in use, and try to unplug it when it's done. There's of course an electrical risk because you've got power cables. Try to keep the batteries and anything like that away from the hot pointy thing. And last but not least, there's an ingestion hazard because of things like lead, so try to wash your hands when you're done. Now to the nitty-gritty of actually soldering. Here's a picture of a typical soldering setup. You have the base, which is what controls the temperature of the iron. You have a holder to make sure you don't burn yourself. You can have a sponge, which you wet with deionized water, or a little bit of brass sponge, which doesn't need any water at all, and that's what you use to clean the tip. Here's a reel of solder. You can see how it's just a nice little flexible wire. You always want something to help you hold things mechanically in place, And last but not least, you want to have a fume extractor if you're not in a well-ventilated space, some hand tools, and some safety glasses. Soldering is all about the tip you use. Keep in mind that there's a plating on top that you don't want to damage. And there's usually a sweet spot with the tip where you actually get a lot of good thermal conduction. And last but not least, there are a lot of different shapes, so try to use the right shape for the job based on how big what you're trying to solder is. Before we get started, make sure that you don't leave the iron anywhere but in its holder. Try to avoid soldering directly to batteries. If you need to, contact an instructor. Never apply flux directly to the tip of an iron. It'll etch away the coating. And never mechanically file the tip of an iron because that will again destroy that coating. Here's our process. Before turning the iron on, always check the tools and quality. Clean all of your soldering surfaces before turning anything on, and then mechanically connect surfaces as best you can with helping hands, vices, and clamps. Next, take care of your personal protective equipment by wearing some safety glasses and turning on the fume extractor. Finally, when you're actually truly ready to solder, go ahead and set the iron to the appropriate temperature and let it come to temperature. Once it's at temperature, you want to clean the tip by tinning it if necessary. See the next demo. And then there's a 4-phase process. First, apply heat with the iron. Next, once it's at temperature, flow in your solder. Next, remove the wire of solder while leaving your iron still heating the joint. And then finally, remove the iron and allow the joint to cool. Go back to 2. If the tip looks dirty, go ahead and tin it again, and then repeat as needed. One last thing is when you're done, you'll have another process that is described in the next in a following demo video. Here's a quick demonstration on tinning the tip. Here's a quick demo of how to tin a soldering iron tip. First, let's show off all the tools we've got on display. We have, of course, our soldering iron. Here's the base, and there's the holder, and this here is the iron itself. We've also got a bit of copper sponge over here, so I don't need any water. I can just clean the tip with that. I have some solder that has flux in core. This is leaded solder, by the way, so I'm going to be careful to catch all of my leaded waste in a specially labeled container. And I also have a few other hand tools right over here, as well as pretty conventional glasses for eye protection and a fume extractor over here that's not pictured that will catch any harmful vapors. So we want to tin the tip pretty frequently, and so if you're ever unsure of whether or not you should tin the tip, just go ahead and do so. And what it'll do is it'll help clear any of the imperfections that are or impurities that have gathered on the tip. So if you look at the tip and you see that there's a bit of gray or oxidation or black on it, that's a good sign that the tip needs to be clean. If the tip is entirely black, there's nothing you can do and it just needs to be replaced. Contact an instructor for details on that. So to tin the tip, I'm going to follow my soldering procedures. I'm going to dial my temperature in to an appropriate range for leaded solder. I've worked with this solder and this iron a lot, so I know that's roughly the right space. I'm going to turn my iron on because I know it's ready to go. My fume extractor is already on. And with this particular iron, there's a little light here, and that light will start to blink when it actually comes to temperature. Not all irons do this, but if you can, you want to be working with tools that give you the information on when they're ready to go. I'm going to slowly wait for that to come up to temperature. So take your tip, and then you just want to feed a little bit of solder onto the tip, just like that. Try to cover both sides. This is a chisel tip, so I'm covering both sides. And then go ahead and scrape it off again in your little duster. And you'll find that your iron's really nice and shiny. Really quickly, it's very easy to make mistakes while you're doing it. And there's an Adafruit video that's linked in the comments that will show you a great way to desolder anything using either solder suckers or desoldering wick. Last but not least, when shouldn't you solder? If you're dealing with high power or alternating current mains voltage, solder can remelt and splatter, so try not to use it. Anything over 48 volts or over 5 amps, try to use a mechanical or crimping connection instead. And if you don't know what's going on, if you're soldering to an odd material, definitely ask for help instead of just trying to figure it out on your own. There are additional resources available in the comments. Thank you for your time.